Just picking up from an earlier video where you may remember we went through part A. I'm not going to go through that now because that's already been done in detail. This is a follow-on video in which we look at the second part of the question, part B. Okay, so we're being asked to evaluate tan to the 6 x dx from 0 to pi on 4, and conveniently we have a reduction formula which will allow us to do this efficiently. And the beauty of this method is that we don't actually need to do any manual integration of anything, as you'll come to see. So similarly, we reinvoke our reduction formula. So in other words, we're using this reduction formula I sub n for 6, so we're going to substitute 6 into that n. And then it's just a case of using this formula here. So 1 on n minus 1, what's that? That'll be 1 on 6 minus 1, which is 1 on 5, minus, just to make that explicit, that should be an I, and minus I to the sub 6 minus 2, which is 4. Okay, so now this is kind of like a recursive process. Now previously we have I sub 4. We're going to reapply this formula within our first application of the formula. That's what I mean by recursive. So I sub 4, in other words, is 1 over 4 minus 1, which is 1 over 3, minus I sub n to the minus 2, which is 2. And once again we recursively apply. And 1 over 2 minus 1 is 1 over 1, in other words, so that's 1. Minus, hang on a second. Yeah, we're on the right track. I just realized I have to be careful with the signs. This is where you need to be careful. Let me make this explicit here, see? And then that sign would of course apply to both terms in this expression. And that is where we need to be careful. It's good that I made that oversight, because then now I made that explicit to you and you won't make the same mistake. So just to finish off the problem, where are we up to? Yes, 1 minus I to this, I to that, in this case is 2 minus 2, which is 0. Now we can't do another application of this reduction formula, because of course it only applies for all n greater than or equal to 2, and we've reached our limit. We're now at the point where n is 0, so we have no choice but to leave it in that form. And remember, once again, the signs, you've got to be careful. In this case it's fine because it's a positive, but as we saw earlier, the signs are liable to change, so be careful with that. And expanding. Okay. So now all that's left is to complete our solution minus, we're just going to have to now restate the original integral explicitly, because we don't know how to, we can't use this reduction formula for this n equals 0 case. So, however, this is something we can easily accomplish without the use of reduction formulas. You can see, well, what's the integral of tan to the 0? Well, that's anything to the 0, as you would know, is simply 1, is equal to 1. So what are we really asking? 1 is a constant, of course, so the integral of a constant, let me write this out. The integral of a constant, 1 of dx, is simply going to become, let me just get to that bit. It's simply going to become, when we integrate it, it's just going to become x from 0 to 4, and of course this is assuming you know how to do basic integration. Obviously I wouldn't imagine you would be even have any reason to look at this video if you didn't already know how to do basic integration, which I will cover at some other time in some other video, so be sure to come back to my site. And of course what that means is we're going to take this minus 0. Why? Because remember, it's really x from 0 to pi on 4, so we just substitute pi on 4 and 0 into x minus x in each case, and that gives us, well, let's see, it's always good to do these explicitly, although some of you can do it in your head. I'm a bit rusty with my math at the moment, so we're going to make it a common denominator. 15 minus 5 over 15 plus 15 over 15 minus 5 over 4. All this constant terms can become 3 minus 5, which is minus 2, plus 15 is 13 over 15, minus pi and 4, and voila, that's it. That's our answer. That's all there was to it. And I've checked that against the answers. Okay. Well, hopefully you're happy with that. Thanks for tuning in, and be sure to visit my website. Just want to make a pitch for my website. You really should give this website a go. See if you find it helpful. I've been building this over the last 3 months, and here we are. Okay, so you can see that I only have 2 topics up at this stage, but I will be progressively adding to the topics, and I spend a great deal of my time really fleshing out these topics and explaining everything in minute detail. So to my knowledge, I don't really know of a few other sites that comprehensively do this, so hopefully I'm bringing something new to the online math scene. I explain everything in detailed steps. There's visuals that I've created created to complement the text. And if you really think that this sort of thing is helping you, then please, I urge you to consider donating. It doesn't have to be a lot, but as is mentioned here, I'm basically footing the costs of running this website, and I'm devoting a lot of my time to it. So the least I could do is not expect to have to pay for the maintenance costs. So please, if you sympathise, if you think this website is genuinely helpful, and if you want to ensure the survival of this website into the distant future, please do consider donating. Thanks for your time, and please visit www.mathannotated.com. See you next time.